Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Presently we are studying Marine Auxiliary Systems and Deck Machinery. Today we have 13th lecture and the topic is Scavenger Air Cooler, Economizer, Evaporator and Condenser for refrigeration plant. In this tutorial, we will first learn about scavenging and supercharging. Then we will discuss about the construction and operation of Scavenger Air Cooler. Next we will learn about Scavenger Air Cooler element with solid drawn flattened tubes. Then we will learn about the construction and operation of Economizer. Next we will learn about fin and tube type evaporator. Then we will learn about grid coil evaporator. Next we will learn about construction and operation of shell and tube type condenser. Lastly, we will discuss about selection of heat exchangers for various ship services. Let's discuss these through the following slides. Scavenging and supercharging. What is scavenging? Scavenging is an essential process in two-stroke marine diesel engines used for ship propulsion, which supplies the engine cylinder with fresh charge of combustion air for the next cycle and drives out the exhaust gases produced in the previous cycle. Why there is need for scavenging? As the two-stroke diesel engines do not have their individual intake and exhaust strokes due to shortage of available time, these processes are combined and achieved by scavenging. How is the scavenger supplied to the engine? Turbocharger is used for supplying scavenger to the engine, which consists of a centrifugal compressor driven by a gas turbine using the engine exhaust gases. Compression of air is associated with rise in its temperature and reduction of density, which is responsible for low power output from engine with corresponding rise in exhaust gas temperature, causing the burning of exhaust valve and seat. The charged air is thus cooled to reduce its temperature before it enters the diesel engine cylinder. What is supercharging? Supercharging is the process of supplying compressed combustion air to a naturally aspirated four-stroke engine. What is the purpose of supercharging? Supercharging helps the engine to produce extra power by supplying dense air to the engine cylinder. Thus, it is called supercharged engine. Construction of Scavenger Air Cooler. The sketch shows a Scavenge or charged air cooler which has rectangular shaped construction. It consists of two tube plates, a fixed and the other free to expand. A number of tubes are attached to the tube plates by expansion and bell mounting. As the air has relatively poor heat transfer property, Scavenger Air Cooler tubes are always equipped with copper fins to improve the heat transfer by increasing the surface area. The fixed expansion flange allows the free movement to the tube plate on this side. The expansion joint seals the air and prevents its leakage. Tube plates are closed by a water box on each end. Corrosion of water boxes due to seawater, when directly used for cooling, is prevented by use of sacrificial anodes. Cooling water enters the front water box through lower connection, passes through the lower tube bed, takes a turn at the rear water box, flows through the upper tube bed, and leaves the front end cover from the upper connection. An air vent is provided on the front side water box to displace trapped air. Hot air from turbocharger enters from the bottom, flows over the copper fins and gives it heat to the cooling water passing through the tubes, and cooled air is delivered to the scavenge manifold. Scavenger Air Cooler element with solid drawn flattened tubes. The sketch shows a Scavenger Air Cooler element with solid drawn tubes having semi-flattened cross-section, which are occasionally used and preferred than tubes of circular cross-section. Flattened tubes are passed through thin copper fin plates and bonded to them with solder for maximum heat transfer. Heat of the air is absorbed by the fins and given to the tubes. Cooling water passing through the tubes takes away the heat with it. On modern ships, central fresh water is used as coolant for removal of heat, which obviates the need of frequent cleaning as in case of seawater system. Low temperature cooling water requires regular treatment to maintain its alkalinity. Cooling of the air results in precipitation of moisture, which is removed by water eliminators fitted at the air outlet site. A change of direction is used to assist water removal. Condensate is removed by a drain connection beneath the moisture eliminator. Regular monitoring of scavenger air temperature provides fairly good indication regarding the condition of cooler and requirements for its maintenance. The only attention that the heat exchanger requires is to ensure that heat transfer surfaces remain substantially clean and flow passages are generally clear of obstructions. On smaller engines such as generator engine, the whole cooler is removed from its air trunking for cleaning on the air side, whereas in case of large engines for propulsion arrangement is provided for chemical cleaning in place. Water side can be inspected or cleaned by removal of the water boxes and brushing through the tubes. Economizer. The sketch shows an economizer, which is the waste heat recovery unit. An economizer is used as feed water heater on steamship boiler, whereas it works as a steam generator on motor ships using the exhaust gases of diesel engine. The economizer consists of a number of plain tubes on which cast iron gills are shrunk on. The gills protect the inner tubes from cold and corrosion, which occurs due to condensation of sulfurous acid in the exhaust gases when their temperature drops below 170 degree Celsius. The gills also improve the heat transfer due to increase of surface area by about 6 times, but causes the deposition of soot due to restriction of gas passage. Low sulfur or gaseous fuels being presently used may not require gills as in earlier years when diesel oil was used during engines part load operation with plain tubes. The return bands are plain without the gills, which are used to connect the gill tubes. Return bands do not form the part of the heat transfer member, as the exhaust gases do not flow around them. Gill tubes are supported by tube plates on either side and also provide free expansion and contraction. Tube plates also form the passage for exhaust gases. Sealing rings between the tube plates and plain ends of the gill tubes prevent the leakage of exhaust gas towards return bands. The heating coils thus formed by gill tubes and return bands are connected to inlet and outlet headers stubs by welding. Feed water enters the economizer coil through the inlet header at the bottom, receives heat from the surrounding exhaust gases and leaves from the outlet header on the top. Exhaust gases before leaving the boiler or after the diesel engine turbocharger enter the bottom of economizer. After exchanging their heat in the economizer, the gases leave through the funnel. Fin and tube type evaporator. The sketch shows a fin and tube type evaporator used in refrigeration and air conditioning plants. Evaporator is a heat exchanger through which the cold refrigerant flows to absorb heat from the surrounding air. The evaporator consists of a number of straight fin tubes, end of which are connected with tube ends to form a cooling coil. Liquid refrigerant is supplied to the evaporator by expansion valve at low pressure, which begins to boil at low temperature as it absorbs heat from the air. Air is circulated by a fan around the fins, which improve heat transfer. When sub-zero temperatures are maintained In cold rooms such as in meat or fish room, electrical heating elements are provided between the cooling coil to defrost the evaporator. A frosted evaporator has poor heat transfer due to reduced airflow across the fins. Evaporator is automatically defrosted periodically. The flow of refrigerant and air through the evaporator are stopped during the defrosting. Evaporator is equipped with a tray and drain pipe to remove the water. The evaporated refrigerant is then drawn out of the evaporator by the compressor. Compressor maintains the evaporator pressure and corresponding temperature, which is achieved by varying the compressor capacity. Grid coil evaporator. This sketch shows a grid coil evaporator which is commonly used in household refrigerator but is rarely used in moderate size refrigeration plant. This evaporator relies on natural circulation of air due to which cooling rate is very slow. The cold room consists of heavily insulated walls and a door to prevent the heat inflow from the surroundings. As the heat transfer between the refrigerant and surrounding air is by natural convection current, the cooling coil requires long tubing and large quantity of refrigerant. Defrosting the cooling coil is very difficult and requires hot gas technique. In comparison to grid coil evaporator, fin and tube type evaporator, generally called a unit cooler, is more efficient, very compact and easy to maintain. Similar to the unit cooler, liquid refrigerant is supplied by the expansion valve and slightly superheated vapor is drawn out by the compressor, thus maintaining the required pressure in the evaporator. Marine refrigeration condenser. The sketch shows a shell and tube type condenser designed for high pressure which is used in moderate and large size refrigeration plants. Condenser for small units are of fin and tube type, very similar in construction to the evaporators discussed earlier. Water-cooled condenser is very compact in comparison to air-cooled condenser as water can remove the heat 15 times faster than air. Condenser consists of steel cylindrical shell. In medium-sized plants, condenser shell also acts as a receiver and a side glass is equipped near its bottom to monitor the refrigerant level. Tube plates of Admiralty brass are attached to both ends of the shell flanges with fiber gaskets to prevent the leakage of refrigerant. Cupro-nickel or aluminum brass tubes are attached to the tube plates by expansion and bell mounting, thus forming the tube stack. Tube plates are closed by water boxes or end covers which provide the supply of coolant through the tubes. The coolant enters through the bottom connection, passes through the tubes. It is usual to have a two-pass arrangement which facilitates cleaning of the tubes by opening the free end cover. After receiving the heat from refrigerant, coolant leaves the condenser from the upper connection of the water box. Water boxes were prevented from corrosion by sacrificial zinc anodes earlier when seawater was used as coolant. Presently, treated fresh water is used as coolant which does not require regular cleaning of the condenser as compared to seawater system. Hot refrigerant from the compressor enters the shell through the top and surrounds the tube stack, gets condensed and is collected at the bottom. Liquid refrigerant leaves the condenser from the bottom connection. Large condensers are equipped with liquid outlet on both ends to provide continuous supply of liquid refrigerant during ship's rolling and pitching movement. Condenser shell is protected against the overpressure by a relief valve. Top of the condenser shell is equipped with an air vent to release any air in the system. Similarly, the water boxes are also equipped with air vents to release any trapped air in cooling water spaces. Selection of heat exchangers for various ships services. Following heat exchangers are used in engine room for various ships services. Lubricating oil cooler. Shell and tube type coolers are used for lubricating oil of small systems such as generator engine, steam turbine, hydraulic oil, etc. Whereas plate type coolers is used for main engine where piston is also cooled by the lubricating oil. Freshwater cooler. Freshwater coolers for diesel engine are of shell and tube type, whereas plate type coolers are used for central freshwater system. Compressed air cooler. Compressed air coolers for main and topping up compressors are usually of U-tube type but may occasionally be of shell and tube type. Air-cooled compressors for services such as emergency air, service air, deck air or breathing air are of fin and tube or coil type. Scavenger Air Cooler. Scavenger Air Cooler for the diesel engine are of fin and tube type. Steam condenser. Steam condensers are used on all motor ships for dumping the excess steam while at sea using exhaust gas boiler, commonly known as atmospheric condenser. Atmospheric condenser is also used for creating vacuum in large steam condenser while using air injectors. Shell and tube type vacuum condensers are used where steam is used for producing mechanical power such as driving propulsion turbine or steam ships, driving turbogenerator on steam ships or container vessels, or driving cargo oil pump turbines on conventional oil tankers, which may be of the regenerative type. Freshwater heater. Freshwater heaters are used on the ship for heating domestic water, commonly known as calorifier, and for heating main engine jacket cooling water during port stay to keep the engine warmed up for immediate use. Both are of shell and tube type heaters in which water passes through the shell and steam through the tubes. Economizers or feedwater heater. Economizers or feedwater heaters are usually of the plain or gill tube type across which the flue gases flow. Seawater heater. Seawater heaters are used on conventional oil tankers for washing the cargo tanks and lines while preparing them for inspection or repair and during dry docking. Seawater heaters are of shell and tube type where seawater flows through the tubes and the steam passes through the shell. Fuel and lubricating oil heaters. Fuel oil heaters for diesel engine and boiler and lubricating oil heaters for purifiers are of shell and tube type, although heating of fuel and lubricating oil in storage, settling and service tanks is carried out by heating coils located at the bottom of these tanks. Evaporators and condensers in freshwater generator. Evaporators and condensers used in freshwater generator are both shell and tube type and plate type. Shell and tube arrangement was conventional method, whereas plate type arrangement is a later development. Evaporators and condensers in refrigeration plant. In earlier times, when large quantity of refrigerated cargo was carried in cargo holds, shell and tube type evaporators were used as primary evaporators for cooling the brine in engine room, and coil and fan unit as secondary evaporator in the cargo holds. Condensers of modern size refrigeration plant are of shell and tube type, whereas fin and tube type condenser is used for smaller units. This completes the study of heat exchangers. This book is written by me and covers all the topics as per the syllabus specified by Indian Maritime University. It clarifies the concepts with simple illustrations. The book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. This book can help the students in preparing for the exam and also to work on ship's auxiliary systems and deck machinery safety. Hope that you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You may subscribe to the channel for getting notification about the new tutorials. I will be back with a new lecture shortly. Thanks for watching till the end.